Today we're going to look at chapter 3. Here are the answers for today's questions. Questions 1. When a conductor carries a current, the number of conduction electrons that flow in the conductor for 10 seconds is 3.75 times 10 to the power of 20. Determine the current flows in the conductor. To solve questions 1, let's apply the equations for current. So I equals to Q over T. Now in these equations, Q represents the total charge. So in order to calculate the total charge, we need to use the numbers of electron times the charge of an electron. Therefore, I can also be written as NE over T. Now let's substitute the values into the equations and we will get I equals to 6 ampere. Questions 2. Two nichrome wires have equal lengths, but the diameter of the second wire is double that of the first wire. What is the ratio of the resistance of the second wire to that of the first wire? To solve questions 2, let us go through the information given. The information given is about the length of the wires and also the diameter of the wires. So let's apply the equation for resistance where R equals to rho L over A. Since you are given two sets of information in the questions, now let us list down the information in the table. So first, let's look at the information about L. Question tells you that now both nichrome wires come with the same length. Therefore, we can say L1 equals to L2 equals to L. And for set 2, it is also the same. L1 equals to L2 equals to L. And then when it comes to diameter, the diameter of the second wire is double of the first wire. So for first set of data, just write it down as D1. And for set 2, we write it down as D2 equals to 2D1. But then if you look at these equations, equation is equals to rho L over A. There's no D in the equation. So try to think, what is the information that can be calculated by using diameter? Well, obviously is the area. So you have wire, the shape, the cross-sectional area is circle. Therefore, A can be calculated by using pi r squared or pi d squared over 4. Now, since you are given the diameter of the wire, let's apply A equals to pi d squared over 4. So for set 1 of the data, A1 equals to pi d1 squared over 4, whereas for set 2, A2 equals to pi d squared over 4. Now substitute D2 as 2D1 and eventually you will get A2 equals to pi D1 squared. And then how about the information about rho? What do we know about rho? If you look at the questions again, now it mentions two nichrome wires. So which means now these two wires, they are made of the same material. If they are made of the same material, then it means they have same rho. Therefore, rho 1 equals to rho 2 equals to rho, and for set 2, it is also the same. Rho 1 equals to rho 2 equals to rho. Now that we have the information about rho, L, and A, let us form the equations. So R1 equals to rho L over A1, substitute A into the equations, and if you simplify it, you get 4 rho L equals to pi D1 squared. Whereas for set 2, you will get R equals to rho L over A2 and substitute A2 equals to pi D1 squared. You will get rho L equals to pi D1 squared. So now that you have two equations, let us solve these questions. Since question is asking for the ratio of the second wire that of the first wire. So let us use set 2 informations divided by set 1. So substitute the values into the equations. We have R2 over R1 equals to rho L over pi D1 squared divided by 4 rho L over pi D1 squared. Cancel out the similar term. We then have R2 over R1 equals to 0.25. So this 0.25 is the ratio of the resistance of the second wire to that of the first wire. Question 3. A wire of length 2.5 meter and diameter 0.15 mm has resistivity of 1.90 times 10 to the power of negative 8 ohm meter at room temperature 25 degrees Celsius. Calculate the resistance of the wire at room temperature and at negative 10 degrees C. Given alpha equals to 3.93 times 10 to the power of negative 3 per degree Celsius. To calculate the resistance of the wire at room temperature, just apply the equations R equals to rho L over A. Now, since you are given the diameter of the wire, therefore this equation can also be written as R equals to rho L divided by pi d squared over 4. Substitute the values into the equations. You will then get R equals to 2.69 ohm. Questions B wants the resistance of the wire at a temperature negative 10 degrees Celsius. It is no longer at the room temperature. Therefore, let's apply the equations for the dependence of resistance on the temperature. R equals to R naught, 1 plus alpha T minus T naught. Substitute the values into the equations and you will obtain R equals to 2.32 ohm. That's all for today. I will see you all again on Wednesday.